Okay, good morning. Today, we are going to learn about working drawings. So let's try and understand what are working drawings. You all know that as architects, when we design buildings, they have to be built. And who builds them? It is the contractors. Now, the contractors will have to be given certain instructions so that they can construct the building as designed by us. Now, how do you give these instructions to the contractor? First of all, there are two kinds of bits of information which we have to pass on or convey to the contractor. The first one, what is to be built? And the second, how is it going to be built? So the first part, which deals with what is to be built, is done through drawings. Because you all know that as architects, our language is that of drawings. So when you want to convey to the contractor what is to be built, what you do is prepare a set of drawings which explain very clearly to the contractor what is it that needs to be built. Now, how is it going to be built is given to him through another document, which is a written document, which explains in very explicit terms what is the method to be adopted for this building and what materials are to be used and so on and so forth. All this is called as specifications. Now, writing specifications is something that we will study in the next semester. But right now, what we're going to look at is how do you make this set of drawings which are given to the contractor to tell him what is to be built. This set of drawings is called working drawings. Why is it called working drawings? Because it is used as an aid or as a guide for the work that is going to go on. Now, what are the various purposes for which working drawings are made? Obviously, the first purpose I have already talked about, and that is to guide or to instruct the contractor as to what is to be built. But there are some other uses that working drawings are put. Apart from giving instructions to the contractor, you all know that before the contractor is appointed, the owner wants you to give him an estimate of cost. How much is the building going to cost him? And how does one find that out? By looking at the working drawings, which explain in detail what the building is like, and finding out quantities of various materials, various items of construction that go into making up of the building, and find out rates for these different items of construction, multiply both the quantities and the rates, and you get the final estimate of cost, or how much is the building going to cost. It is obvious that if you want to find out detailed cost of the building that is going to be built, you will need detailed drawings, because you have to actually get the measurements from the drawings. Then later on, when you call for tenders from contractors, we have to also include the working drawings in the tender form, so that the contractor can study the drawings and have a fair idea as to what is to be built. Later on, when a contract document is executed between the owner and the contractor, working drawings form part of the contract documents. Now, later on, in case there is any kind of dispute, then the working drawings together with the specifications are used for the purpose of dispute resolution. So working drawings also have a legal status when it comes to their being part of a contract document. So these are some of the purposes for which working drawings are used. But what is it that is contained in the working drawings? what all things are included. So let's see one by one. There is a site plan. There are details of the foundation in terms of plans and sections. There are floor plans. There are sections. There are elevations. Now you will have realized by now that the drawings that we make are two-dimensional drawings, two-dimensional slices of the building. Even though the building is in 3 dimension, drawings are in orthographic projections, something that you have already learned in first year. Now, the drawings that we make, I think there are people have not realized that they have to be muted. Anyway, the working drawings that you make, they also need to include other details like structural drawings, drawings about services, sanitation, water supply, electrification, HVAC, etc., etc. Even landscape details, site development details, all these also have to form part of the set of working drawings. You can really understand that not only are these drawings included, but they are integrated in the main working drawing or set of working drawings. For instance, if you have a plumbing detail, the pipe has to run through the walls, outside the walls, which means adequate provision for the pipe to pass through, first of all, on top of the floor and then out of the wall for the downtake. All this has to be included in your main drawing, correct? Because the main drawings are going to be used by the contractor, the subcontractor, the labor force to actually work on site. So they ought to know that later on there is a pipe which is going to go through this wall. So this is just one example. There are hundreds of examples like this, that when drawings for different services, including structural design, when they are made, they have to be integrated into your main working drawing so that there are no clashes. So you suddenly don't end up where in a situation where you have to actually do a drill or do core cutting through an RCC element like beam, which is dangerous. Now that can only happen if your services are not integrated into your main working drawings initially. This is this used to be quite difficult initially, but now there is something called as BIM, Building Information Modeling. What does it do? BIM is, it's a software which many of us already use. Some of these very popular softwares are Revit. Okay. Now, what it does is that it takes or it builds a complete 3-dimensional model of the building, and it integrates everything. So if there is a structural element like a column and a beam, it is included in that 3-dimensional model. Now, if you use a BIM, the chances of clashes will be less. I'm not saying they will be eliminated. They can still be clashes, but they will become evident to you in the BIM. In 2-dimensional sets of drawings like plans and sections, when you integrate drawings from various other consultants, it is not so easy to find out whether there are clashes. Now with BIM, what has also happened is that it can generate 2-dimensional drawings which are very similar to your working drawings. So making working drawings has become easier if you are using a BIM. So we will go ahead to the next part of our discussion. Now, when you make these drawings, and as I said, that drawings are our language, every language has its own grammar. Now, when you make working drawings also have to follow a certain grammar of its own, and that is called standards. What are the standard methods in which you make working drawings? Okay. And I've already told you that working drawings will include site plans, floor plans, foundation details, detailed sections, elevations, detailed drawings of different components of the building like doors, windows, staircases. Then shop drawings, or short for workshop drawings. There are certain elements in the building which have to be either manufactured in a workshop or they are manufactured on site and then assembled. For instance, you bring wood and you can make a door frame, and then you assemble that door frame and put it up. So these kinds of elements which have to be prepared or created or manufactured, you need to make separate sets of drawings for them. They are called as workshop drawings or shop drawings. Now, all these kinds of drawings, they have to be made in a certain manner. You have to follow certain conventions. As I said, that there are standards. In India, we follow the BIS. Okay, Bureau of Indian Standards has prepared standards and we follow them. Internationally, there are two other kinds of standards. There is the ISO. You must have heard this word quite often. International Standards Organization. So they have their own standards, and the Americans have their own standards called the ANSI standards, NSI. But we follow the British method, which is also the international method, or which is also adopted by BIS, and that is the ISO standards. Now, what do these standards talk about when it comes to working drawings? First of all, they talk to you about how different parts of the working drawing, elements of the working drawings are to be done. To start with, there is lines, or there are lines, different kinds of lines. There are thick lines, there are thin lines, there are dotted lines, there are dashed lines, and there's a combination of all this. Now, all of this, or there are bold lines and there are faint lines. Now, all these have certain meaning. Where do you use a type of line? For instance, if you have cut a material and it is in section, then it is shown with bold line. What is there in elevation is shown by a light line or a thin line. So, line conventions, they are there. Secondly, there are conventions about various materials that are used. How will you show various materials, especially when they are in section? Like if it is wood and if it is cut, then you show it with a certain hatch. If it is concrete, you show it with a certain hatch. So there are hatch patterns which you use to indicate different types of materials. Then there are leader lines and arrowheads. I hope that you know what is the meaning of this. If you have been using CAD, you would know that sometimes you have to annotate, you have to write that, give a name of a part in a drawing. Now for that, you use an arrow and a leader line, and then you write the text. So how do you use the leader lines and arrows? What types of arrowheads you use there are standards. Then there is this whole question of dimensions. Now, dimensions play a very important role in working drawings. Imagine that your drawing is going to be used by the workman on site. Let's say that you want to construct a brick wall. Then the workman will have to know what is the length of the brickwork, what is the height of the brickwork. And that you cannot leave to chance. You'll have to write, you'll have to dimension out each and every part of the wall and give correct dimensions. You cannot leave anything to chance. Remember, your workman may be good at masonry, but he may be very bad in arithmetic, like most of you. So, you don't force him to do any multiplications, calculations, additions, subtractions, etc., on the drawing. You give every detail, every dimension has to be mentioned. Now, this is to be done in a certain manner. So, how do you write dimensions? There are conventions which you will have to learn. Then the entire set of drawings which are made in as a portfolio, like a book. So there is a certain sequence in which the drawings have to be organized. Also, one must understand that drawings will contain a lot of information, and sometimes in our enthusiasm we put too much information on a sheet. which can actually be very confusing for someone who is reading the drawing. Take for instance, you are making, let's say, excavation plan to show how where you are going to excavate. Now, if in your enthusiasm you also put the floor details or the slab details or the column details on that, what will happen? The person who is going to excavate will not understand what is this, what is all this information for. So you have to give only that set of information, that part of information which is required by that team of people who are constructing at that time or at that stage of construction. Okay, now how do you do it? Very simple. Since you're using computers, you know that there is the facility of creating layers. So you can create many layers on your floor plans and only print those layers which are necessary at that time. Okay, so this way, even though your drawings will have all the information, when you give out a drawing at a specific juncture, kind of team of workers, you only include that information which is relevant to that worker. All right. Having said this, can you have drawings of different sizes, some very long, some very short, some very tall, and make a portfolio? Obviously, no. So there are conventions about paper sizes. What paper sizes can you use to make drawings and to print them? Now, what are these paper sizes? You're all aware of the standard paper sizes. You have been, in fact, using them. There is A0, A1, A2, A3. Usually for working drawings, we tend to use A1 and A2. Sometimes A0, but A0 is too large a piece of paper to unfold and fold every time on site. So usually we don't do that. The more often used paper sizes are A1 and A2. Okay. Then there is a certain format in which you make these drawings on these sizes of papers. First of all, we never use portrait. We always use landscape, like that. Okay. Not vertical, but horizontal. And then on that piece of paper, we put our logo, our names, our written information, who has drawn that, all that sort of stuff, that is put on the right hand side vertically. Not like some of you, who put the entire sheet, at the bottom, you put that information in a horizontal band. That is not done for working drawings. Working drawings, the all the information has to be formatted and put on the in a vertical fashion on the right side. The purpose is that you get a more squarish area of paper to put your drawings on. There is even a convention as to what is the border that you have to put. How do you put the border? It is normally 10 mm on three sides, but on the side where you actually bind it, that side it is 20 mm and not 10 mm. So these kinds of conventions exist, and we will have to study all these sorts of details that we give. Then there are very important the scales. Different types of drawings have to be drawn to different scales. For instance, floor plans, sections, elevations, they will always be drawn to at least 1:50. Sometimes even 1:20, but 1:50. Never 1:100 or 1:200. Site plan 1:500 or 1:200. And then there are working details. Suppose you want to do details for doors or windows. There, the main part is done in 1:20, but then there are scales of 1:10, 1:5, 1:2, 1:1, and sometimes even 2:1 and 5:1. So what is 2:1 and 5:1? That means the drawing is twice or 5 times larger than the actual object. Now, where do you want to do this? Maybe when you design very intricate details of some kind of assembly which is made in the workshop. So there at times you have to even blow up the details. But there are a standard set of scales that you can use. What scale to use is not left to you. All right. I have already talked to you about uh, BIM, or building information modeling, how you can use it. Nowadays, there is also a tendency that some architects just give the BIM itself to the contractor. But I don't think it's a very good idea, because the contractor may understand the BIM, but on site you need a drawing, because the workman is not going to open a laptop and look at a drawing. So even though BIMs are useful, finally you will have to take slices out of the BIM and print them as separate working drawings. Now, there are two other things that we are going to look at. First of all, after the building is complete, there are certain changes that happen during construction on site. That is always inevitable. When that happens, they have to be recorded on your drawing. And these corrected drawings, with whatever changes are there, which are already incorporated, these sort of drawings are then finally created as record drawings, or they are also called as built drawings. Okay, as the word very clearly states, they are showing how the building is built actually. So as built drawings have to be created by converting your working drawings, by making changes into them, and this set of as built drawings has to be given to the owner after the work is complete. Obviously, if these drawings are not given, what will happen? After 10 years, when some repairs work is going to take place, the owner will not know what is inside the building. He has to know all that, right? Especially when you're dealing with services. Typically, you will find uh, it's a commonplace occurrence that there is a problem in the toilet. There's some leakages, and you have to dig out the entire floor to see first of all where the pipes are. Now, if the as-built drawing is there, then you would know where the actual pipe is running, and you can only kind of open up that much part and repair. So as-built drawings have also got to be prepared.